Hi, Sonny. Here's the circuit. Um, I'm going to send you a link to this so you could actually watch it work on your screen too, if you want to. Now, right now I've got this running with 5 volts. These are switches. Here's switch 1, switch 2, switch 3, and switch 4. And I just want you to see that those are the things that are coming into the system, and this is what it does. And the brain of this low-tech version is this what's called a 555 timer. It's really small, smaller than your pinky nail. It's really tiny chip. And um, these switches up here are actually the 3 tilt sensors that we have. So the first one, this first switch is 10 degrees. This next switch is 25 degrees. And then this final switch is 45 degrees. And so here's how it works. First thing you do is you power on the system. So the system is on. We have an indicator to show that it's on. For the purpose of this demonstration, I'm using a green LED for a power light and a red LED, of course, for the trigger. So right now the system is on, and with all 3 switches open, this would be what it would be like if you were standing correctly. So you were standing perfectly straight up, or you were looking up even higher. But the moment you start to look down, from 1 degree until 10 degrees, you get this switch right here that closes with the trigger. That activates the 555 timer through a capacitor and stores up energy enough to spit it out, which gives you a timing of this red blinking light. You can see this is a moderate alarm. Now, after that, if you were to keep leaning over past 10 degrees, you would see the next switch, which is right here. And what that does is it changes the resistance and creates a faster pulsing light through the 555 timer. And finally, the worst case is when you've triggered all 3 sensors, you've leaned over really far. That triggers the same sequence, but it blinks this fast. And to show you something else that I built into the system, because this is a trigger switch and it works by gravity, if you shake your head, you would see this red light go off a lot as you shook your head. And that's something that I've been really concerned with using this low-tech method. So what I built in is there's a delay first. That's why there's kind of some craziness going on here. There's a delay first before this alarm goes off, and I'll show you what I mean. So when you trick this sensor, watch, trip, on, trip, on. So you see that slight delay there? I think that's going to solve the case where we're letting the ball's going to have to keep making contact for this amount of time before any kind of alarm will start to go off. So I'm pretty sure that this is going to keep us in the gold. We're going to be great. Now we may need to adjust a little bit of this resistance once we have the prototype, which I'll be building later today. But this is the official full-length circuit, and also to show you that this first switch, because we have that nice delay in there, it actually controls the next 2 switches too. So what's nice about this is if this switch is off, the first 10 degrees, then these 2 are off too. So it's going to eliminate any jitter that's going to exist in these automatically, because these 2 are dependent on this one also. So with this configuration, we're using 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 components plus the timer and our 3 tilt sensors and of course the battery. Now something else is this is 5 volts, and I've really been wanting to get this to a lower voltage, so I'm going to turn the voltage down. You can see that I built these capacitors in such a way to where the system will still run on 3.7 volts. But you see how dim that is? I don't know actually what that's actually going to look like in the real world. After I get the prototype out, I'm going to be able to put in the 3.7 and kind of test this. And it may be that if we really like the low voltage option better, we could have another component, which I left out to save us money, but another component that would turn off the green light and only show the blinking red when there was a tilt sense switched. I do think, though, that we will need some way of letting the user know that the system is on and it's working. So I'm going to take it down to 3 for a sec to show you that the coin cell batteries, this is the system running on one coin cell. So it will not run on one coin cell with this 555 timer. It actually does run, but it's not enough juice to get through to the red LED. And I did try this without the green light just to see was it worth pushing and changing the whole thing down to get it down to one coin cell. The only way we could get it to one coin cell is if we do the initial version I sent you, where it literally is just on or off. And personally, I don't think that's what we want. But I just wanted you to know that I've been thinking about that. But fear not, because this could easily run on 2 coin cells, because I made the capacitance where it still functions at the max voltage of 10 volts. Right now you're seeing that this light is blasting, and it's just because I just forgot to change this capacitor for this demonstration. Sorry about that. But this thing actually will run at a higher voltage too. It's just a matter of that I just need to switch it for, instead of a 47, we went with 100. I had changed that to 47 for a different experiment. Sorry about that. So this will run even off 2 coin cell batteries without a problem too. Now this is really low voltage, like super low milliamps. We're looking at 20 plus an intermittent 20, so there's 40. And then the 5.5 timer itself, it's actually a little bit harder to compute how much. I'm going to do a computation for you and let you know, but what I'm trying to say is that these coin cells are going to last well over any length of a game that you could have. I'm really confident about that, but don't quote me on that, because wait for me to give you that initial report for the voltage and things like that. So that's an update for now. This is the circuit that we're going with. Of course, if something about what you see here doesn't make you comfortable, please, or makes you uncomfortable, please let me know. We can certainly change that. You know that, of course. That's all I got for now. I hope this helps, and I'm looking forward to showing you the next bit. All right, thanks. Bye.